Hello, welcome to In 5 Minutes. Next part is the negative clipper. What you can see in the diagram. Again, it is a series clipper because diode and the load resistance both are in series. Negative clipper means it will clip off the negative half cycle of the entire input waveform and it will keep as it is the positive half cycle. Now, how to go about the analysis of that? So, in this circuit, when you apply KVL in this part, what will be the equation for KVL? From input to output will give you VI minus voltage across diode. Ideally we are considering it as 0 minus VO equals to 0. That means VO is VI. Since we are considering voltage drop across diode is 0. If practical diode is given, so voltage drop will be 0.7. So in that case your equation will be VO equals to VI minus 0.7. This is the only difference between the ideal and practical case. In this case we are getting VO minus VI. This is what you will get for practical case, or if the voltage drop across diode is given as 0.7 volts. VO will be VI. When VO will be VI only when the diode is short circuited. So in the positive half cycle, what you can see over here is positive terminal of the diode and positive terminal of the supply. Both are in the same phase. That means the supply voltage will forward bias the diode in the positive half cycle. So your circuit in the positive half cycle will look like this. The diode will be shorted, then the load resistance RL, your input voltage plus minus VI, and the output voltage VO, which is satisfied by the equation written VO equals to VI. So your VO will vary in accordance with VI in the positive half cycle. That means if your VI is varying from 0 to 4 volts, your VO will vary from 0 to 4 volts in the positive half cycle. This is the analysis in the positive half cycle. Now moving to the negative half cycle, what will be there in the negative half cycle? Negative half cycle, the diode will be reverse bias because the positive terminal is connected. Now in the negative half cycle, you will have the negative terminal connected here, positive here. So positive of the diode is connected to the negative of the supply, which will reverse bias the diode, and in the negative half cycle, the diode will be reverse biased. The circuit will look like diode will be open circuited, load resistance RL, the output voltage VO. Now since there is no current in the circuit, the current through RL will be 0, hence the output voltage VO will be 0. For the entire negative half cycle, your VO will be 0 volts. So you won't get any output in the negative half cycle. Hence it is called as negative clipper. It is flipping of the negative part of the input waveform. Hence it is called as negative clipper. Now how to draw the waveform? Now for the waveform, you can see in the positive half cycle you are getting the output. Hence in the positive half cycle you can see the output voltage. For input of positive half cycle, which is going from 0 to 4 volts, you are getting the output similar from 0 to 4 volts. In negative half cycle, it is clipping the entire negative half cycle. The yellow line is just shown for the projection of the positive and negative half cycle. So in the negative half cycle, it is clipping the negative half cycle, so you are not getting any output in the negative half cycle. Hence in negative half cycle, the voltage is 0 volt. Now how to draw the voltage transfer characteristics? Coming to the voltage transfer characteristics, x-axis you have input voltage, y-axis you have output voltage. As your input voltage varies from 0 to 4 volts, your output is varying from 0 to 4 volts. So in the transfer characteristics, what you can say is, as your input is varying from 0 to 4 volts, your output is varying from 0 to 4 volts. Hence the graph is linear from 0 to 4 volts. In the negative half cycle, you can say 0 to minus 4 volts, you are not getting any output. So 0 to minus 4 volts, the characteristics is this. So this is how the voltage transfer characteristics is drawn for the negative clipper. These are called the output waveforms, or you can say waveforms, and the transfer characteristics. This is the entire analysis of the negative clipper.